All right, ladies, in this video, we're going to go through the harder questions in 7D. So I'm going to start off with question 7. So question 7, you have to complete the square and then sketch, whereas prior to that, question 6, you were already given it in the turning point form. So question 7, we're kind of completing the square and then we're sketching it. So let's have a look at 7A. Now, just while I'm writing this down, I'm sitting in the grade 2 classroom. And there's a, not sure what's next door, maybe a grade 1 class. And it was quite cute listening to the little kids talking to their teacher. Okay, when we're completing the square, we always look for the coefficient of x. So we keep the first two terms the same, so x squared plus 4x. Then whatever this coefficient of x is, we add that divided by 2 squared. So that just means we're going to be able to put this into a perfect square. But because we've added it, we've also got to subtract it, because if we don't, we're kind of changing the quadratic into something else. And then we've got plus 3. So let's have a look at factorizing these first 3 terms. Whatever you have here in your bracket, we'll just go x plus 2 squared. Okay, so that we've factorized the first 3 terms. And then we've got minus, so let's just do this quickly. So 4 over 2 is 2, 2 squared is 4. So just double check that, 2 squared. Okay, so then we've got x plus 2 squared minus 4 plus 3 is minus 1. And I should put y equals there because they are all equations. Okay, so then we've got it in turning point form. Now, I can see straight away my h and my k. So h is -2, k is -1. So remember, if you need to, you can write that as negative. We are dealing with a positive parabola, so it's going to look like that. And we've got to also label our intercepts. So to find the x-intercepts, let y equal 0. So we're going to have x plus 2 squared minus 1 equals 0. X plus 2 squared. Bring that 1 over. Now to get rid of the squared, we take the square root of both sides. So the square root of 1 is positive or -1, and then you can separate it. So we've got x plus 2 equals positive 1, x plus 2 equals -1. So x equals, bring that 2 over as a negative, so 1 minus 2 is -1, and -3. And remember, your turning point is halfway between your x-intercepts, so it should be x equals -2, which it is. Good. Okay, so I always like to check things like that. Oh, your y-intercept is when x equals 0. So let's just write that. Oh, actually, do you know what? We don't have to substitute x equals 0, because if I go back up to the start, we've already got it in expanded form. When it's in expanded form, your constant is your y-intercept. So you could either substitute x equals 0, or notice that your, oh my gosh, I'm having such blanks today. Your y-intercept is at 3 because of that constant. Okay, so let's sketch it now. So I'm going to go over the next page. Okay, so we had x-intercepts at -1 and -3. We had a y-intercept at 3. And we had a turning point at, I know it was -2 and something, I can't remember, -1. So I'm going to put -1 on. Okay, so, and then -2 is here. So our turning point is here at -2, -1. We've got our 2 x-intercepts there, and our y-intercept. Now remember, parabolas are symmetrical. So if you wanted to do another point, see how we've gone from here, we've gone across 1, up 3. We can do that on the same side here, across 1 to -4, up 3, and there's another point on the graph. So let's just do this in another color because I've done quite a few colors here. Okay, and then just drawing the dots. Oh gosh, my hands are so cold and I can't even draw. Okay, so obviously I wanted to go through that point there, but my hands are very, very cold, so I couldn't do that. All right, let's do a -1. So I'm going to get rid of all of that. So let me just check oh, I was hoping some would be negative. I wonder if there's any that wouldn't. I'd say all of them will actually be, actually let's do F, just out of curiosity what that might be. Y equals x squared minus 2x. I think they're all going to go through, they're all going to have x-intercepts. Okay, but maybe the harder ones, maybe when we get to 9. Okay, so first of all, we've got to complete the square. Keep your first two terms the same. Then we take the coefficient of x, divide it by 2 and square it. And then whatever we do here, we've got to subtract. And then subtract 15. Okay, so we're now simplifying these first 3 terms. Whatever is in this bracket, so -2 divided by 2, which is -1. And then we've got -1 squared is 1. Okay, so this is going to go through the x-axis. All right, so this is a parabola with a turning point at 116, -16. Your y-intercept, so remember we can read that straight from the equation in expanded form, is at -15. If you want to write that as coordinates. And your x-intercept, we let y equal 0. So just, I already had it on the screen. I was going to scroll up so I could see it, but I could already see it. So we've got 0 equals x minus 1 squared minus 16. Bring that 16 over to the other side. I think we're going to run out of room here. Take the square root of both sides. So we're going to have x minus 1 equals the square root of 16, which is positive -4. So we've got x minus 1 equals 4. X minus 1 equals -4. So x equals 5 and x equals -3. And halfway point between those two. So if we added them together, we get 2. 2 divided by 2 is 1. Where's my turning point? There it is. We can see that's right. Okay, oh, we do have a bit of space. Okay, so we need to sketch this now. So it is a positive parabola. They're all positive parabolas that we're doing for question 7. Okay, so our x-intercepts are at 5. So let's put 5 over here. Now notice how I never do a scale. I think when you do a scale, things get messy and there's expectations of what it should look like. -15, we're going to be right down here. -15. And your turning point is at -16. Oh gosh, maybe I should change that a little bit. Let's make that -16. And a point just above it, -15. That's terrible. Not to scale at all, girls, but we're just sketching now. So we've got the key features. Okay, so there's your y-intercept, your x-intercept. Now your turning point was at 1, -16. So down here, and I might just write that like that. And let's join our dots. Okay, so let's see how I go with this one. Oh, it's a bit nicer than the previous one. It's not over yet though, isn't it? Okay, and there's your parabola showing those key features of your graph. All right, let's do another question. Let me just read question 8. Okay, so question 8, I think we're going to be dealing with surds or fractions in our answers. Okay, so that's what it means by exact values, whereas before we were dealing with whole numbers, which was nice. But I'm going to skip them because I don't want to make this video too long. See question 9, it says complete the square and decide if the graph of the following quadratics will have 0, 1 or 2 x-intercepts. So if your equation is in the form like that, in turning point form, you're going to have 1 x-intercept. If it's in either this form or this form, whoops, that's a negative. Oh, hold on, that should be a plus. That's a negative. You're going to have no x-intercepts. This first quadratic is a positive that's gone up. The second one is a negative that's gone down. So no x-intercepts for them. And if it's in this form, oops, let's call that a positive first. We'll do the positives. Or, let me just erase that because it looks like a T. Okay, if it's in either these two forms, so a positive quadratic. Hold on, what am I doing? Gosh, I'm not functioning too well on Monday. Okay, if it's a positive quadratic that's been shifted down or a negative quadratic that's gone up, you're going to have 2 x-intercepts. Okay, so that information is important to have. So I'm just going to scroll back up if you wanted to pause it. And that A could be a positive or a negative. It doesn't matter. Okay, but here, positive parabola that's gone up or a negative parabola that's gone down, you have no x-intercepts. And then here, a positive parabola that's gone down or a negative parabola that's gone up, you have 2 x-intercepts. So that might help you with question 9. Now, I did want to do question 14 because we're looking at non-monics here, and you might come across these if you go on to do methods, probably not next year, but maybe in year 12. So I'm not going to do this question because not all of you are going to do it, but some of you might like the challenge. So I'll just talk you through it. So we're taking out a common factor. Okay, so to be able to complete the square, we need the coefficient of x squared to be 1. So you can see here our coefficient of x squared is 3. And if we took out, so 3 isn't a common factor of, well, it is a common factor of 6, but it's not a common factor of 1. So we can't take, you might think, oh, I can't take 3 out as a common factor as you would in question 10. Okay, so question 10, you can take out the common factor, easy peasy Japanesey. But in question 14, what you need to do is this 1 becomes a third. So you're basically still completing the square, but you're just dealing with that fraction there, which doesn't actually complicate things too much. The steps are there for you. Just because you're dealing with a fraction doesn't make things, it does make it a little bit harder, but the steps are still the same. Okay, so if you can complete the square, you'll be able to do these non-monics, and I strongly encourage you to have a go at doing them. And I'm just thinking now, maybe we'll do one, just because I feel like I'm saying, oh, have a go, you'll be fine, and maybe you won't be fine. So let's do 14a together. Now I'm looking at the other questions, and they do look a little bit harder. When you've got a negative, so k, see how it's a negative 3? Take that out as your common factor. Take the negative out as your common factor. Okay, so we've got 4x squared plus 8x plus 3. Okay, so we're going to take out, I'm just going to get rid of the purple pen. Take out 4 as your common factor. So we've got x squared plus 2x plus 3 on 4. Okay, so when you take out that 4, okay, the 3 becomes 3 on 4. Now, that 4 just stays out the front. So I always like to use square brackets if we're going to be using curved brackets as well. So we've got x squared plus 2x Now, take the coefficient of 2, divide it by 2 and square it. Okay, so we're basically completing the square. And then we subtract it, and then we add the 3 on 4. Okay, so now we can we can factorize this into a perfect square. So we've got x plus whatever this is inside your bracket, which is 1 squared. And then we've got minus 1 squared, which is just 1, plus 3 on 4. And scroll. Oh, I don't have enough. Oh, is that another page? No. Okay. So we've got now 4. Keep your square bracket, and I'll explain why in a second. When you're adding fractions, I always find it's easier to have them as the same denominator. And I'm just going to get another page. Okay, so I've just rewritten it here, so I've got a bit of space to write it. So again, keep that 4 there, the x plus 1 squared. Okay, so minus 4 on 4 plus 3 on 4. So we now have the same denominator, so just work with your numerator. So negative 4 plus 3 gives you negative 1 over 4. Now this 4 out the front multiplies both. Okay, so sometimes that people forget that, and that's why it's important to do the square brackets. You can see here they've used curved brackets. I like square brackets because it's kind of like, curved brackets say, oh, I'm here, I'm just, keeping things together, whereas square brackets are like, take notice of me. I'm important. Don't forget about me. So let's just expand. So the 4 comes with this bracket. And then the 4 times negative 1/4, so 4 times a quarter gives you 1. Okay, and there is your quadratic. And because it's an equation, we'll put the y equals on the front. Now, we need to sketch it. So our value, our turning point, is h. So because that's a positive there, you can turn it into 2 negatives. So you know that h has got to be a negative. So our turning point is at -1, -1. To find your y-intercept, remember that is just your constant. So if we go back to A, you can see that's 3. But if not, if you had it just in turning point form, remember you let x equal 0. Now to get your x-intercepts, you let y equal 0. So let's just scroll down. So we've got 4x plus 1 squared minus 1 equals 0. Oh gosh, can I scroll down? Good. Okay, and we're just solving for x now. So divide now both sides by 4. So that disappears. X plus 1 squared equals 1/4. Get rid of the squared sign. So we've got x plus 1 equals the square root of 1/4. Now, this is why it was good that we've just done surds, or we did surds a while ago, but hopefully you can remember when we take the square root, we're just taking the square root of the numerator and the square root of the denominator. So we're going to have, first of all, a positive and a negative because we're taking the square root. And the square root of 1 is 1. The square root of 4 is 2. So our 2 solutions can be rewritten here. So we've got x equals, take that 1 away. So half take away 1 is -1/2. And then -1/2 take away 1 is -1.5. Now, I always find it easier to work with improper fractions. So if you wanted to rewrite that as -3 on 2, you can. All right, so let's just sketch it. Oh, I'm running out of room. Let's just sketch it quickly over here. Not ideal to do that. Okay, so what have we got? What's our information? Okay, so we've got a turning point at -1, 1. Oh, sorry, -1, -1. We have a y-intercept at y equals 3. Oops, and there's that point there. 3. Oops, probably should do it up here. And then our x-intercepts are at -0.5 and -1.5. So we're either side here. So that's -0.5 and -1.5. Just highlight them. Okay, and our y-intercept. Now, if you wanted to, you can make it kind of symmetrical just to help you join the dots. Okay, so we're going up like that and up on the other side. Good. All right, girls. Good job. Bye.